Alright, so welcome to a video on combinations, and again, this is something that I'm just getting back to teaching, so there may be some mistakes. For example, this is actually the second take of this video because I made a mistake on the first slide that you're about to see the first time I did it. So I had to erase everything and come back and retry it. So, combination is a selection of objects in which order is not important. So it is not important, the order. So think about if you are passing out the same candy to 5 people, it doesn't matter, everybody's going to get the same piece of candy. The order isn't important. Well, the order may be important to them, especially if they're a little kid. They may want the candy first. That way they're cooler than everybody else, but that's neither here nor there. So, we are going to list all possible combinations of 2 letters from A, B, C, and D. So we're going to list all the combinations there. And like we did with permutations, I like to start with one letter and say you're first, list everything, next letter you're first. That's just how my brain works. If yours works different to get these all written down, that's fine, but after you're done, you should have 12 combinations listed. So we start out with A, and we have a B, then we have a C, then we have a D, then with B we have BA, BC, BD, then with C we have CA, CB, CD, and then with D we have DA, DB, and DC. So we've got 12 combinations there, but we have a problem. We've got some doubles. Because order doesn't matter, things like AB and BA, they're the same thing. Just because the letters are in a different order, that doesn't matter, it's not important. We don't want doubles, so we have to get rid of those doubles. And realistically, you can get rid of them anyway. Like with my A, B, and BA, we could mark out the AB, leave the BA, or we can mark out the BA and leave the AB, which that's the way I'm going to go. So I'm going to leave my A's there just because alphabet makes me happy if that one's first. So we have an AB and a BA that's marked out. We have an AC, we also have a CA. We got to mark that out. We have an AD, we also have a DA. So we got to mark that out. Now I'm going to look at my B's. We have a BC and a CB. Those are the same. We have a BD and a DB. Mark that out. And then we have a CD and a DC. So we mark that out as well. Fortunately, D doesn't get to go first in the way we did it, but it doesn't matter because it's going to get the same piece of candy anyway. And now we look at all of our combinations we have left, and we have 1, 2, 3, 4, 5, 6. So it is 6 possible combinations of 2 letters from the letters A, B, C, and D. So with combinations, we have this thing where we're going to have doubles since the order is not important. And this mark out method and this writing out method isn't going to work very well if we have a lot of choices. Like if we were doing the whole alphabet and we were just choosing 2 letters from all the combinations, that would take a while because 26 letters. Whew. We spend a whole day doing that. So let's look at our formula because this will make things easier. So the formula here is NCR, with the C obviously meaning combination, just like with permutation it was a P. And the formula is a little different. So if you recall, our permutation formula looked like this. So the one difference between these two is this times R factorial. And the reason that's there is for that double. So what we're essentially done to this is we've taken the permutation formula and then we've thrown in this times r here, factorial, to get rid of our doubles. So that's what that little addition does there. So let's take a look at it here. We're going to do for permutation 2 versus for combination 2. So for our permutation, it's going to be 4 factorial divided by 4 minus 2 factorial versus, like Mortal Kombat versus, let's see which one's going to win. So we do 4 factorial divided by 4 minus 2 factorial times that 2 factorial. So this gives us 4 factorial divided by 2 factorial, which is 12. And then this gives us 4 factorial divided by 2 factorial times 2 factorial. Which gives us 3 as our answer. So you can see what happens here whenever we take out those doubles. We took out the doubles and we went from 12 possible choices to 3. Okay, so last slide here, we're going to do an example. So with this example, I put at the top ignore song length because I know someone's going to say, well, some of the songs I listen to are like 2 minutes, so it's not going to take very long. And some songs are like 7 minutes. If you listen to some old classic rock songs, those can last like 6, 7, 8 minutes or more. So we're going to ignore the song length here and just answer the question for what it is. This isn't a real life question. This is practicing with combinations. So I'm not going to try to fool you here and make it seem like, hey, look, this could actually happen. Not really. So let's just get practice with that formula. So you are getting ready for a game and want to get pumped up. You have 20 songs in your playlist and only have time to listen to 5. So we're going to see if how many combinations of 5 songs are possible. So again, we need to remember that the big numbers on the left are n. That's the number of objects. Then we have our combination. And then we have how many of our given times it's happening. So it's 5 songs. We put this into our formula of 20 factorial divided by 20 minus 5 factorial times 5 factorial, which equals 20 factorial divided by 15 factorial times 5 factorial. And again, I'm going to do a little trick here to make this a lot easier to put in the calculator. If you can figure it out, that's good. If you can't figure it out, you need to ask me so we can go over it. Okay, so let's change that 20 factorial to 20 times 19 times 18 times 17 times 16. And down here, we're just going to have 5 times 4 times 3 times 2 times 1. And we're going to do that in the calculator. And our top of our fraction becomes 1,860,480 divided by 120, which goes down to 15,504 possible combinations. That's a lot of combinations of songs. So again, your calculator is also able to just do this by putting in this part in the calculator. And if you want to know how to do that, please ask me. I can show you how to do that so you can check your work. But I do want to see all these things when you do the work, at least. And then if you want to type in the calculator, that's fine. But I don't want to see this part here and then you go straight from there to there. Don't want to see that. Also, I want you to make a note and think of how big would this number be if we hadn't done that. Because just with the 20 times 19 times all that, we got 1,000,000. Our calculator could not handle doing 20 factorial. And as I try to type it in my calculator now, it gives me a very, very big number that I cannot write out. It's got about 30 digits. So these are things where we are going to have to use calculator tricks. You got to figure those out too, so make sure you're asking. All right.